exercise 5.3 from questions 1 to 10. So in the first question, they're asking us to find the sum of the following APs. In the first one, the given AP is 2, 7, 12 up to 10 terms. We know that the sum of an AP is given by the formula Sn is equal to n by 2 times a plus an. And since they've given up to 10 terms, we need to find the a10th term of this AP. So we need to find a10. So in order to find a10, we know that the formula is a plus n minus 1, which is 9, times d, which is 5. So a10 is equal to 2 plus 45, and a10 is equal to 47. So now we're going to substitute the value of a10 in this formula. Sn is equal to n by 2 times a plus an. So S10 is equal to 10 by 2 times a, which is 2, plus an, which is 47. So S10 is equal to 10 divided by 2 is 5, and 47 plus 2 is 49. So 49 times 5 is equal to 245, which is the sum of the first 10 terms. In the second question, they've given the AP as negative 37, negative 33, negative 29 up to 12 terms. So first we need to find the 12th term of this AP. So we know that A12 is equal to negative 37 plus 12 minus 1 is 11 times D. So the value of D is equal to negative 33 minus 37. And negative 3 plus 37 is equal to 4. So A12 is equal to negative 37 plus 11 times 4. So A12 is equal to negative 37 plus 44. Then the value of S12 is equal to 12 divided by 2 times A, which is negative 37, plus A12, which is equal to 7. So 12 divided by 2 is 6, and negative 37 plus 7 is negative 30. So the value of S12 is equal to negative 180. In the third question, they've given the AP as 0.6, 1.7, 2.8 up to 100 terms. So first we need to find A100. So we know that A100 is equal to 0.6 plus 99 times 1.1. So A100 is equal to 0.6 plus 108.9. So A100 is equal to 109.5. So next we need to find S100. So S100 is equal to 100 divided by 2 times A, which is 0.6, plus 109.5. So 100 divided by 2 is equal to 50, and 0.6 plus 109.5 is 110.1. So 50 times 110.1 is equal to 5,505. In the fourth question, they've given the AP as 1 by 15, 1 by 12, 1 by 10 up to 11 terms. So here we know that the value of A is 1 by 15, and the value of D is equal to 1 by 12 minus 1 by 15, which is equal to 1 by 60. So first we need to find the value of A11. So the value of A11 is equal to 1 by 15 plus 10 times 1 by 60. And we'll be able to cancel the zeros from 10 and 60. So we will get 1 by 15 plus 1 by 6. So 1 by 15 plus 1 by 6 is equal to 7 by 30. So now we need to find the value of S11. So S11 is equal to 11 by 2 times A, which is 1 by 15, plus 7 by 30. So in order to make sure that they both have the same common denominator, we can multiply 1 by 15 times 2 on both the numerator and the denominator, so that we'll get 30 as a common denominator. So S11 is equal to 11 by 2 times 2 plus 7 by 30. So 11 by 2 times 9 by 30. So we will get 99 by 60. So this we can cancel out. And when we do that, in the third table, we will get 33 over 20. In the second question, they're asking us to find the sums given below. So in this question, they've given the last term, but they haven't given us which term of an AP 84 is. But we know that 84 is the nth term of this AP. So first we need to find the value of n. So here we know that the value of a is equal to 7. And the value of d is equal to, we're going to convert 10 1 by 2 into a mixed fraction, so it'll be 20 1 by 2 minus 7. And 21 by 2 minus 7 is equal to 7 by 2. So the value of d is equal to 7 by 2. So now we need to find out the value of n. So we're going to take an is equal to 84. And we know that 84 is equal to 7 plus n minus 1 times d, which is 7 by 2. So 84 is equal to 7 plus 7n minus 7 by 2. 84 is equal, we're going to multiply 7 by 1 with 2 on both the numerator and the denominator, so that it has 2 as a common denominator. So 14 plus 7n minus 7 by 2. And we're going to bring 2 over to the left-hand side, so 84 times 2 is equal to 14 minus 7, which is equal to 7, plus 7n. And 84 times 2 is equal to 168, which is equal to 7 plus 7n. And when we bring 7 over to the left-hand side, it will become 161 is equal to 7n. And 161 divided by 7 is equal to 23. So now that we know the value of n, we're going to find the value of Sn. So S23. S23 is equal to 23 divided by 2 times a, which is 7, plus 84. Since 84 is the last term of the AP. So 23 divided by 2 times 7 plus 84 is equal to 91. So 23 times 91 divided by 2 is equal to 2093 divided by 2. So when we can write this in the mixed fraction form as 1046 1 by 2. In the second question, they've given the AP as 34 plus 32 plus 30 up to 10. And 10 is the last term of the AP. So an is equal to 10. And we know that an, which is 10, is equal to 34, which is a, plus n minus 1 times d. And the value of d here is equal to negative 2. So 10 is equal to 34 minus 2n plus 2. And 10 is equal to 36 minus 2n. So 10 minus 36 on the left-hand side will equal negative 26, which is equal to negative 2n. And the negative signs will get cancelled, and the value of n is equal to 13. So now that we know the value of 13, we'll find the value of S13. And S13 is equal to 13 divided by 2 times 34, which is a, plus an, which is 10. So 13 divided by 2 times 44. And 2 and 44 will get cancelled, so it'll be 22. So 13 times 22 is equal to 286, which is the value of S13. In the third question, they've given the AP as negative 5, negative 8, negative 11, all the way up to negative 230. So first we need to find the value of n, and the value of an is equal to negative 230. And we know that an, which is negative 230, is equal to a, which is negative 5, plus n minus 1 times d. And the value of d here is negative 8 minus of minus 5, which is equal to negative 3. So negative 230 is equal to negative 5 minus 3n plus 3. And negative 230 is equal to negative 2 minus 3n. And when negative 2 is brought over to the left-hand side, it'll become positive. So it'll be negative 228, which is equal to negative 3n. And the value of n here is equal to 76. So now we're going to find the value of S76. So S76 is equal to 76 divided by 2 times negative 5 minus 230. So 76 divided by 2 times negative 235. And 76 divided by 2 is equal to 38. So 38 times negative 235 is equal to negative 8,930. In the third question, in the first one, they've given that a is equal to 5, d is equal to 3, an is equal to 50. We need to find the value of n and Sn. So first, in order to find the value of n, they've given that an is equal to 50. So we can write that an, 50, is equal to 5 plus n minus 1 times d, which is 3. So 50 is equal to 5 plus 3n minus 3. And 50 is equal to 2 plus 3n. And 2 when brought over to the side becomes 48 is equal to 3n. And the value of n is equal to 16. Now we need to find the value of Sn. So S16. S16 is equal to 16 divided by 2 times a, which is 5, plus an is 50. So 16 divided by 2 is 8, and 50 plus 5 is 55. So 55 times 8 is equal to 440. So the value of S16 is equal to 440. In the second question, they've given that a is equal to 7, a13 is equal to 35. We need to find the value of d and S13. So we know that a13, which is equal to 35, is equal to 7 plus 13 minus 1 is 12 times d. So now we can find the value of d. So 35 minus 7 is equal to 28, which is equal to 12d. And we need to find the value of d, so d is equal to 28 divided by 12. So we can simplify this in the 2's table. So 6 2's are 12, and 14 2's are 28. 3 2's are 6, and 7 2's are 14. So the value of d is equal to 7 by 13. So now they're asking us to find the value of S13. We know that S13 is equal to 13 divided by 2 times 7 plus 35, which is A13. So 13 by 2 times 35 plus 7 is equal to 42, and 2 and 42 will get cancelled. So 13 times 21 is equal to 273. So the value of S13 is equal to 273. In the third question, they've given the value of A12 as 37, the value of D as 3, and we need to find the value of A and S12. So in order to find the value of A, we already know the value of D. So we can say that 37, which is A12, is equal to A plus 11 times 3. So 37 is equal to A plus 33. So the value of A is equal to 4. Now they're asking us to find the value of S12. We know that S12 is equal to 12 divided by 2 times A, which is 4, plus A12, which is 37. So 12 divided by 2 is 6, and 37 plus 4 is equal to 41. So the value of S12 is equal to 41 times 6, which is equal to 246. So in the fourth question, they've given the value of A3 as 15, S10 is equal to 125. We need to find the value of D and A10. So they've given the value of A3 as 15. So 15 is equal to A plus 2D. And they've given the value of S10 as 125. So 125 is equal to 10 divided by 2, which is 5, times A, 2A plus N minus 1 times D. And we need to find the value of D and A10. So 125 is equal to 5 times 2A plus N minus 1 times D. And we know the value of N is equal to 10. So 5 times 2A plus N minus 1 is 9D. So we will notice that we have two equations which are in the form of a linear pair of equations. So we can use either the substitution method or the elimination method to find the values of A and D. So 125, since 5 is in multiplication, we can bring it over to the left-hand side, will become division, is equal to 2A plus 9D. And 125 divided by 5 is equal to 25. So 25 is equal to 2A plus 9D. And the first equation we have is 15 is equal to A plus 2D. So using the elimination method, we can write the first equation here. So 15 is equal to A plus 2D. So let us multiply the second equation times 2. So we will get 25 is equal to 2A plus 9D, and 30 is equal to 2A plus 4D. So we're going to multiply the second equation with the negative sign so that we can cancel 2A and negative 2A. So we will get 25 is equal to 2A plus 9D, and negative 30 is equal to negative 2A minus 4D. And negative 2A and positive 2A will get cancelled. 25 minus 30 is equal to negative 5, which is equal to 9D minus 4D, which is equal to 5D. So the value of D is equal to negative 1. So now that we know the value of D as negative 1, we need to find the value of A in order to find the value of A10. So we're going to substitute the value of D is equal to negative 1 in the first equation. So we will get 15 is equal to A plus 2 times negative 1. So 15 is equal to A minus 2. So A is equal to 17. So now that we know the value of A as 17, we can find the value of A10. So A10 is equal to 17 plus 9 times D, which is negative 1. So 17 minus 9, which is equal to 8. So the value of A10 is equal to 8. In the fifth question, they've given that D is equal to 5, S9 is equal to 75. We need to find the values of A and A9. So we know that S9 can be written as 75 is equal to N9 divided by 2 times 2A plus N minus 1, which is 8 times D, which is 5. So now we'll be able to find the value of A. So 75, we can bring over 2 to the left-hand side. It will become multiplication. So 75 times 2 is equal to 9 times 2A plus 8 times 5, which is 40. So 75 times 2 is equal to 18A plus 9 times 40, which is equal to 360. So 75 times 2 is equal to 150, which is equal to 18A plus 360. So 18A is equal to 150 minus 360. So we will get A is equal to negative 210 divided by 18. So when we simplify this, we will get the value as negative 35 over 3. So now that we know the value of A, we need to find the value of A9. So A9 is equal to negative 35 over 3 plus 8 times D, which is 5. So negative 35 over 3 plus 40. So the value of A9 is equal to negative 35 plus 120 divided by 3, which is equal to 85 over 3. In the sixth question, they've given that A is equal to 2, D is equal to 8, and Sn is equal to 90. We need to find the value of n and an. So Sn, which is equal to 90, can be written as 90 is equal to n divided by 2 times 2 times a, which is 2, a is equal to 2, plus n minus 1 times d, which is 8. So now we'll be able to find the value of n. So 90 times 2 is equal to n times 4 plus 8n minus 8. So 90 times 2 is equal to n times 4 minus 8 is negative 4 plus 8n. So 90 times 2, which is equal to 180, is equal to negative 4n plus 8n squared. So now we have a quadratic equation. So we'll get the values of n, we'll get two values of n. So we can simplify this equation and write it as 2n squared minus n minus 45 is equal to 0. So when we factorize this quadratic equation, we will get 2n squared minus 10n plus 9n minus 45 is equal to 0. Because we need to find two values which add up to negative 1 and multiply to negative 90. So the two numbers are negative 10n and positive 9n. So when we factorize this, we will get 2n times n minus 5 plus 9 times n minus 5. So the values of n are negative 9 by 2 and positive 5. Since the value of n cannot be a fraction or a negative number, we will take the value of n as 5. So now they're asking us to find the value of an. We know an is equal to a5. So a5 is equal to 2 plus n minus 1, which is 4, times d, which is 8. So 2 plus 8 times 4. So the value of a5 is equal to 2 plus 32, which is equal to 34. In the 7th question, they've given that the value of a is equal to 8, an is equal to 62, and Sn is equal to 210. We need to find the values of n and d. So they've given that the value of an is equal to 62. So 62 is equal to 8 plus n minus 1 times d. And they've given that Sn is equal to 210. So 210 is equal to n by 2 times 2a, which is 16, plus n minus 1 times d. So we will notice that n minus 1 times d is common in both equations. So we can write the first equation in the terms of, we can find the value of n minus 1 times d and then substitute that value here in order to find the value of n. So when we bring 88 to the left hand side, we'll get 62 minus 8, which is equal to n minus 1 times d. So 62 minus 8 is equal to 54. So the value of n minus 1 times d is equal to 54. So we'll substitute the value of 54 here in order to find the value of n. So 210 is equal to n by 2 times 16 plus n minus 1 times d, which is equal to 54. So 210 is equal to n by 2 times 16 plus 54, which is equal to 70. So 210 is equal to 2 and 70 will get cancelled, so we'll get 35. So 210 is equal to 35n. So the value of n is equal to 210 divided by 35. So the value of n is equal to 6. So now that we know the value of 6, we need to find the value of d. So we can substitute the value of n in an is equal to 62 in order to find the value of d. And we already know that an is equal to a6, so a6 is equal to 62. So 62 is equal to 8 plus 5 times d, and 62 is equal to 8 plus 5d, and 62 minus 8, 54, is equal to 5d, and the value of d is equal to 54 divided by 5. In the 8th question, they've given that the value of an is equal to 4, the value of d is equal to 2, and the value of Sn is equal to 14, negative 14. We need to find the values of n and a. So we know that an, which is equal to 4, can be written as a plus n minus 1 times 2. So 4 is equal to a plus 2n minus 2. So 6 is equal to a plus 2n. And the value of a can be written in the terms of 6 minus 2n. And similarly, Sn, which is equal to negative 14, can be written as n by 2 times a plus 4. And since we've already written a in the terms of 6 minus 2n, we can substitute the value of 6 minus 2n in replacement of a. So negative 14 is equal to n by 2 times 6 minus 2n plus 4. So negative 14 is equal to n by 2 times 6 plus 4 is equal to 10 minus 2n. So negative 14 is equal to n times 5 minus n. Because we can cancel out the 2, and 5 times 2 is 10, and 2 times 1 is n. So negative 14 is equal to 5n minus n squared. So now we have a quadratic equation, and we need to solve for the value of n. So n squared minus 5n is minus 14 is equal to 0. And now using the factorization method, we can write this equation as n squared minus 7n plus 2n minus 14 is equal to 0. So n times n minus 7 plus 2 times n minus 7 is equal to 0. So the value of n is equal to negative 2, or the value of n can be positive 7. We know the value of n cannot be negative or in a fraction, so the value of n can be taken as 7. So now that we know the value of n, we're going to find the value of a. So since the value of an, or a7, is equal to 4, we can write 4 is equal to a plus 6 times 2. So 4 is equal to a plus 12. And the value of a is equal to negative 8. In the 9th question, they've given the value of a is equal to 3, n is equal to 8, s is equal to 192, and they're asking us to find the value of d. So Sn is equal to 192. So 192 can be written as n by 2, which is 8 divided by 2 times 2a plus n minus 1 times d, which is 7 times d. So 192 is equal to a divided by 2, which is 4, times 2 times a, which is 6, plus 7d. So when we bring 4 over to the left-hand side, it becomes division. So 192 divided by 4 is equal to 48. So 48 is equal to 6 plus 7d. And 6, when brought over to this side, becomes 42 is equal to 7d, and the value of d is equal to 6. In the 10th question, they've given that the last term of the AP is 28. The sum of the total terms in the AP is 144. And there are total 9 terms in the AP, and we need to find the value of a. So since they've given that the last term of the AP is 28, we can say, and then there's 9 terms in the AP, we can say that a9 is equal to 28. So the value of n is equal to 9, and the value of an is equal to 28. And they've given the sum of S9 is equal to 144. And we need to find the value of a. So we know that S9, or 144, is equal to n by 2, which is 9 by 2, times a plus an, and an is equal to 28. So 2, when brought over to this side, becomes multiplication. So 144 times 2 is equal to 9a plus 28 times, which is equal to 252. So 2 times 144 is equal to 288, which is equal to 9a plus 252. So the value of 9a is equal to 288 minus 252. So 36 is equal to 9a, and a is equal to 4. In the 4th question, they're asking us to find out how many terms of the AP 9, 17, 25 must be taken to give a sum of 636. So they're asking us to find the value of n, and they've given the value of Sn to be 636. So here we can say that the value of A is equal to 9, and the value of D is equal to 8. And we need to find the value of n. And they've given that Sn is equal to 636. And 636 is equal to n divided by 2 times 2a, which is 18, plus n minus 1 times d, which is 8. And we need to find the value of n. So here we'll get a quadratic equation, so we'll get two values of n. So 636 times 2, because when 2 is brought over to the side, it becomes multiplication. Or we can keep it on the right hand side itself. So 636 is equal to n by 2 times 18 plus 8n minus 8. So 636 is equal to n by 2 times 18 minus 8, which is equal to 10, plus 8n. 636 is equal to n times 5 plus 4n, since 2 and 10 and 8n will get cancelled. So 636 is equal to 5n plus 4n squared. And now we need to solve for this quadratic equation. So we need to find two numbers which add up to 5n and multiply to 636 times 4. So two such numbers would be 4n squared, positive 53n, and minus 48n, which is equal to 0. So now we need to factorize this equation. So when we factorize this equation, we'll get n times 4n minus plus 53 minus 12 times 4n plus 53. So the value of n is equal to negative 53 divided by 4, or n is equal to 12. Since the value of n cannot be in a fraction or in a negative form, we can say that n is equal to 12. In the fifth question, they've given that the first term of an AP is 5, and the last term is 45, and the sum of all the terms in the AP is 400. We need to find the number of terms and the common difference. So they've given that the value of AL is equal to 45, the value of A is equal to 5, and SN is equal to 400. So we know that 400 can be written as n by 2 times 5, which A plus AN, so 5 plus 45. So now we'll be able to find the value of n. So 400 is equal to n by 2 times 50. And 2 and 50 will get cancelled, so we'll get 25n is equal to 400. So the value of n is equal to 16. Now that we know the value of 16, we can write that A16 is equal to 45. And we need to find the value of d. So 45 is equal to 5 plus 16 minus 1, which is equal to 15, times d. So 5 when brought over to this side becomes 40 is equal to 15d. So the value of d is equal to 40 divided by 15, which is equal to 8 divided by 3. So in the sixth question, they've given that the first and the last term of an AP are 17 and 350 respectively. If the common difference is 9, we need to find how many terms there are and what is their sum. Since they've given A is equal to 17 and AL is equal to 350, D is equal to 9, and we need to find the value of N and Sn. So first we need to find the value of N. So AL, which is 350, is equal to 17 plus N minus 1 times D, which is 9. So 350 is equal to 17 plus 9n minus 9. So 350 is equal to 17 minus 9, which is equal to 8 plus 7n. 9n. So 350 minus 8 is equal to 342, which is equal to 9n. And the value of n is equal to 342 divided by n, divided by 9, which is equal to 38. Now that we know the value of n, we can find the value of Sn. So Sn, or S38, is equal to 38 divided by 2 times a plus an, which is 350. So 38 divided by 2 times 367. So 38 divided by 2 is equal to 19 times 367, which is equal to 6,973. So in the 7th question, they're asking us to find the sum of the first 22 terms of an AP, in which the value of d is equal to 7, and the 22nd term is 149. So first we need to find the value of a. So we can write 149 is equal to a plus 21 times 7. So 149 is equal to a plus 147. And the value of a is equal to 2. So S22 is equal to 22 divided by 2 times a, which is 2, plus a22, which is 149. So 2 and 22 will get cancelled, so it will be 11 times 149 plus 2, which is 151. So 11 times 151 is equal to 1,661. In the 8th question, they're asking us to find the sum of the first 51 terms of an AP whose second and third term are 14 and 18 respectively. Since they've given A2 is equal to 14 and A3 is equal to 18, we can write 18 is equal to A plus 2D and 14 is equal to A plus D. And we will notice that we have a system of linear pair of equations, so using the elimination method we'll be able to find the value of D and A. So multiplying the second equation with the negative sign, we will get 18 is equal to A plus 2D, and negative 14 is equal to negative A minus D. And positive A and negative A will get cancelled. 18 minus 14 is equal to 4, and 2D minus D is equal to D. So the value of D is equal to 4. Substituting the value of D in the second equation, we will get 14 is equal to A plus 4. So the value of A is equal to 10. So now that we know the value of A and D, we can find the value of A51, and then we'll find the value of S51. So A51 is equal to 10 plus 50 times D, which is 4. So A51 is equal to 10 plus 200. So the value of A51 is equal to 210. So now we need to find the value of S51. So S51 is equal to 51 divided by 2 times A, which is 10, plus A51, which is 210. So 51 by 2 times 220. And 2 and 220 will get cancelled, so we'll get 51 times 110, which is equal to S51. So 51 times 110, which will give us 5,610. In the 9th question, they've given that if the sum of the first 7 terms of an AP is equal to 49, and that of 17 terms is 289, we need to find the sum of the first n terms. Since they've given S7 is equal to 49, we can write 49 is equal to 7 by 2 times 2a plus 6d. And 289 is equal to 17 by 2 times 2a plus 16d. So we will get a pair of linear equations, and then we'll be able to find the value of a and d. So this equation can be simplified as a plus 3d is equal to 7, and this equation can be simplified as a plus 8d is equal to 17. So using the elimination method, we can find the value of a. So multiplying the second equation with the negative sign, we will get Positive a and negative a will get cancelled. 8d minus 3d is equal to 5d, and 17 minus 7 is equal to 10. So the value of d is equal to 2. So substituting the value of d is equal to 2 in this equation, we will get 8 plus 6 is equal to 7, and the value of a is equal to 1. So now we need to find the value of Sn. So Sn is equal to n divided by 2 times 1, 2 times 1, plus n minus 1 times 2. So n divided by 2 times 2 plus 2n minus 2. And n divided by 2, 2 minus 2 will get cancelled, so 2n. So we will get 2n squared by 2. And 2 and 2 will get cancelled, so we will be left with n squared, which is equal to Sn. In the 10th question, they're asking us to show that a1, a2, an form an AP, where an is defined as below, and we also need to find the sum of the first 15 terms in each case. So in order to find the sum of S15, we'll first need to find the value of A15 and the value of A. So first, in order to find the value of A, we're going to take the value of n as 1. So A1 is equal to 3 plus 4 times 1. So the value of A is equal to 7. And the value of A15 is equal to A15, which is equal to 3 plus 4 times 15. And 4 times 15 is equal to 60. So A15 is equal to 63. And we know that S15 is equal to 15 divided by 2 times 7, which is A, plus AN, which is A15, which is equal to 63. So 15 divided by 2 is equal to 70. And 2 and 70 will get cancelled, so S15 is equal to 15 times 35, which is equal to 525. In the second question, they've given that AN is equal to 9 minus 5n. So first we need to find the value of A. So we're going to take the value of n as 1. So A1 is equal to 9 minus 5. So the value of A is equal to 4. Next we need to find the value of A15. And A15 is equal to 9 minus 5 times 15. So 9 minus 5 times 15 is equal to 9 minus 75. So the value of A15 is equal to negative 66. So S15 is equal to 15 divided by 2 times A, which is 4, minus 66. So 15 by 2 times 4 minus 66 will give us negative 62. So the value of S15 is equal to 15 divided by 2 times negative 62, and 2 and negative 62 will get cancelled, so the value of S15 is equal to 15 times negative 31. So 15 times negative 31 is equal to negative 465.